Hello, my name's Callum, and welcome to The Price of Life. Living in the modern world is incredible. We can record fragments of time and watch on little screens. With a click of your fingers, light enters your room. We have warmth and hot showers at our fingertips. And the magic that gives us all of these things is called electricity. So what is electricity? In simple terms, electricity is electrons that move along a wire. Electricity is primarily made from magnets moving around coiled wire. I have a number of videos in the link below going in depth of how electricity is made. So where are these huge amounts of electromagnetic energy coming from in New Zealand? In 2020, 57% of New Zealand's power came from hydroelectricity. 20% came from gas, coal and diesel. 10% came from geothermal energy. 7% from wind turbines. 4% from cogeneration energy, otherwise known as combined heat and power energy, and 1% of other forms of electricity, perhaps solar. All the electricity in New Zealand is interconnected with vast amounts of transmission lines going throughout the country. The North and South Island are connected with the HVDC Inter-Island Transmission Cable. HVDC stands for High Voltage Direct Current. The link between the North and South Island starts at the Benmore Hydroelectric Power Station. It then travels 534 kilometres on overhead transmission line throughout inland Canterbury and Marlborough to Fighting Bay in the Marlborough Sounds. From Fighting Bay, the link travels 40k via submarine cables underneath Cook Strait to Oturanga Bay. It then travels 37 kilometres on overhead lines to Hayward's transmission substation in Lower Hutt. This cable allows electricity to be sent from either island to any area in New Zealand when electricity is low. If you're interested in New Zealand's live power usage per day, I have a link in the description showing all of the live power usages. On the 14th of September 2021 at 10 a.m, the North Island was using 3,553 megawatts of power, and the South Island was using 1,862 megawatts of power. This shows the North Island uses far more power than the South Island. On that same date and time of September the 14th, the South Island live power generation was 2,604 megawatts, coming solely from hydroelectric power. South Island's biggest hydro power stations are the Manapuri, the Benmore, the Clyde and the Roxburgh. On that same date, the live power generation in the North Island was 2,991 megawatts. If you wanted to know more about the different power stations in New Zealand, there is a link in the description below giving you more information on the power stations. So how does electricity get from power stations to your house? For this video, let's show the power journey to the centre of Christchurch. So I'm going to explain the power process in a very basic form for this video. If you want to learn more about power and the different processes and how things work, there is a number of links in the description below. So let's crack on! So first off, the power is generated at a power station. Contact, Genesis, Mercury, Meridian and Trustpower own 95% of NZ's power stations. All of New Zealand's power stations are interconnected on the NZ power grid. The electricity generated then goes on New Zealand's national transmission grid, which is owned and operated by Transpower. Transpower is government owned and owns all the substations. Transpower is the system operator of the wholesale electricity market. Orion is owned by the Christchurch City Council. Orion owns and maintains Christchurch's distribution network, which is connected to the national transmission grid. Orion maintains the power lines, transformers, and everything from the substation to your household, including maintenance and fixing power outages. The power company you choose for your household purchases power from the wholesale spot market. Trades take place at approximately 285 grid injection points and grid exit points. Depending on what power company you choose, depends on where your power could be coming from. For example, Meridian Energy owns the Manapuri Hydro Power Station. Since they own this power station, the power costs from this power station may be a lot cheaper than the power on the wholesale market. Generally, Christchurch power would come from the hydro power stations in the South Island, due to the cheap wholesale prices. However, if water levels become low, the North Island would be sending power down to the Christchurch area. Congratulations, you've made it this far in the video. So now I wanted to talk to you about the environmental costs of power in New Zealand. And I just wanted to talk about the hidden costs of all the workings of making electricity and bringing to your household. Let's begin. Step 1. What is the environmental cost of building and maintaining the New Zealand electricity grid? Let's begin with the power stations. It would take hours to explain all of the maintenance costs for all of the New Zealand power stations, so I'll just give an example of the Manapuri Hydro Station. Here are some pictures of the production process of making a hydro power generator. So I hope all those pictures gave you a rough idea of the colossal size of a power station in New Zealand. The logistics, the machinery, the resources used to build such a big power plant is hard to even comprehend. Think of all the copper, steel, aluminium, magnets, plastics, concrete, wood, and plenty of other resources I haven't even considered would have been used to build this initial infrastructure and also be used for maintenance. Think of all the logistical costs of sending these resources to different factories by trucks, trains, boats, before even arriving at the Manapuri Hydro Power Station. On the Transpower Transmission Network map, there are roughly 50 main power generating stations. So to get an idea of the maintenance and infrastructure costs, you'd have to times all of these considerations by 50. This isn't even including the small generator sites. I also wanted to point out, a lot of the infrastructure has been built to last 50 to 100 years plus. However, there is plenty of other equipment that needs regular maintenance and changes. I have solely expressed the resource cost to the environment here. There's also the costs of using the land and water areas and destroying habitats in the areas where power stations are made. Now it's time for the transmission lines. Transpower New Zealand's national power grid contains 10,969 kilometres of high voltage lines and 178 substations. The main transmission line towers that carry the power lines are roughly 35 metres tall and spaced anywhere from 300 metres to a kilometre in spacings. The steel transmission towers are roughly 28,000 pounds or 12.7 tonne. So a rough total of the amount of steel used for the transmission towers for the NZ power grid is 278,612 tonnes of steel. Depending where the towers are standing, if they're in coastal areas they'll degrade faster, but overall they should last up to 50 years. I also worked out rough estimates of the cable size of ACSR cable that is 1.7 inches in diameter. The ACSR high voltage power cable weighs around 2,300 pounds per kilometre. After doing my calculations, I found there would be 11,440.6 tonnes of ACSR cable on the high voltage transpower transmission grid. ACSR cable is made from aluminium reinforced at the centre with galvanised steel. So that works out to be 11,440 tonnes of a mixture of aluminium and steel. These power lines usually last around 80 years plus, but have considerably less life expectancy in coastal areas, more towards 40 years. These transmission lines also have a number of porcelain insulators, which is another consideration of the resource costs. For each transmission tower, they have to build deep structural footings to hold the transmission towers in place. There is a video in the link below if you want to see how this is done. So I'll briefly talk about substations. A substation has massive transformers that step down the power to safer levels in the area where the power is going. They also have switches to direct power, circuit breakers, etc, etc. There is a great video in the link below showing this. In Christchurch there is the Milton Street substation, the Islington and Bromley substation. I think you get an idea of the size and materials used to make these substations and maintain them. The power then goes through power lines via power poles or underground tubing throughout the city. Once the power is near your house, it goes through another step-down transformer to safe power levels for the home. The power goes through your power meter box, your main circuits board, through your walls, and finally gets to your appliance, your computer you may be watching this video on. Think of all the other hidden costs, the power cables underground, the life of all the resources used, the maintenance, logistics. It's a massive journey to have the magic of power in your home. Another thing to be aware of is the power company you are with. They would have offices, computers, power and maintenance costs to monitor and maintain your power. A final note, the amount of power you use contributes to the amount of power generators needed to use in this country. The more power all of us use, the more infrastructure, the more generators, the more resources used to build and maintain these. I hope you enjoyed the video. If you liked my content, give it a good thumbs up. And if you want to see more, click the subscribe button and join me on my adventures. You can also support me by going to buymeacoffee.com in the link below.